Welcome. Thanks for coming. What I'm going to do is I'm going to start off with the standard template program that is a standard console hello world. And I'm just going to comment out the line that says hello world. So what I'm going to do today is it's kind of stems from the video, the other YouTube video that I've listed in the description. And then I kind of go off script and kind of go my own direction. What I noticed about that video is that it doesn't, the example was so simple, it didn't necessarily have to be an object-oriented example. And so what I'm going to do is I'm going to attempt to do inheritance in a non-object oriented way. Well, let's just get started, I guess. What I'm going to first do is create an animal. And I'm not going to call this a class. I'm going to call it a module. Now my animal is going to have a code section. And by the way, the word code is optional. I just still type it in. And I'm going to make the eat function. And this is the same as the video. And I'm going to invoke console.code.writeLine munch. I have the glitch that IntelliSense doesn't want to disappear if I leave the line all the time. So, like I said, this is still a very new compiler. It has little glitches in it. I'm making videos with a glitchy compiler. It's one of the reasons why I don't have it released or finished for anyone to download. And but here we go. So now let's go back here. And I'm going to invoke animal.code.eat. So let's create that. Let's run that. Munch. Okay. What we just did is we created a module with a function, but it's not object-oriented programming. It's simply a module with a function. That's why I'm not calling it a class. Okay. Now, what I'm going to do is I'm going to go back to the animal, and I'm going to add a data section. Now, the data section is what you'd typically in your other languages call static data, but I'm not going to refer to it as static data. I'm going to refer to it as the data section. And I have a reason for that, but I'm not going to say right now. But I'm going to make a public variable. It's a DW string. So what is a DW string? Where did I pull it out of? Okay, this project is linked to my runtime, DLL, and it has a lot of stuff in the runtime that I've been working on. And DW string is one of the modules that's in my runtime, and this module can act like an object. This is actually object-oriented programming object. And what we're going to do is we're going to create an instance of the object in this project's data section. So it'd be called, you might call that a static object in your compiler. I'm not sure. And I'm going to name it color of blood. Now, I'm going to do something you've probably never seen before. Change the value of color of blood dot text. Now let's do it right here. Variables dot text equals red. Okay. Now what that does is it changes the default value of the color of blood text property to red at compile time. This is not a runtime code that executes. This is changing the data at compile time. And of. Okay. That's why when I type this in lowercase, it didn't change the casing. I didn't put the word of in there. All right, little detail. So now let's go back here, and let's not go back there yet. Let's go down here and let's make another function called echo stats. Invoke console.code.writeLine. Boy, my IntelliSense is popping up glitchy stuff there. I never noticed that until I'm live on a video. I don't know why it doesn't seem to work right when I'm making a video. Anyway, let's keep going here. Color of blood. Let's make that a right so it doesn't wrap to the next line. Console.code.writeLine. Color of blood. Okay. Let's give you my echo function. Let's go over here and let's invoke animal.code.echostats. All right. Let's create that. Let's run that. We have a munch and color of blood is red. Again, notice that nowhere in this program, in my main, do I set it to red. It's done at compile time. Okay. Now what I'm going to do is I'm going to create another module. And let me call it dog. And you can see where this is going to lead into some inheritance, hopefully. Now the dog is going to have some code. And before the code, I'm going to define animal.code.eat as eat. Now, let's just do that for starters. Let's see what that does. So let's do an invoke let's do a dog here. Let's do an invoke. Sorry, my fingers just started doing their thing without following what my head was thinking. Let's do dog.code.eat. So the dog has an eat function. she doesn't like. Okay. Whoa. Again, this is... doesn't like it. Nice. Undefined simple eat. Okay, what did I do wrong? Oh, this will never make it to a video. Let's try to compile this module. Okay. Another compiler glitch I got to deal with is that I had to compile the dog module before it would take the changes. Very annoying. Let's push forward. How embarrassing. Let's create that. Let's run it. Munch, red, dog munch. Okay, so what's happened here is that the animal can munch, and the dog doesn't have any code, but he's kind of defines a function within animal as if it's his own function. This looks just like inheritance to me. Really, it's just a mapping of a different module's function into your own function. These are all publics, by the way. So that looks like inheritance. As far as I'm concerned, it is inheritance in my mind. So you can think of it any way you want. But let's continue because we're going to do more. Now realize that this is not object-oriented programming. This dog is not an object, primarily because it doesn't have any data. And specifically, it doesn't have instance data. So this is my example of inheritance that's not object-oriented programming. But let's continue. We'll go a little more deeper into this. So I am going to write a function under dog. I'm going to call it eat. And this will be typically what you consider to be an override. Chomp chomp. And realistically, you could just comment out this line and just not even have it there. But I'm going to leave it there and call it an override. Really, it's the dog module making up its own eat function. Likewise, I'm going to go ahead while I'm here. I'm going to make another function called howl. And I'm going to invoke console.code.writeLine. What I'm trying to do is I'm trying to make the dog kind of a little different than a regular animal because it can howl. And I'm going to make another function here. I want to show, I'm going to throw in here what I think is called encapsulation, which is pretty much private and public functions. So by default, all these functions have been public. And now I'm going to write a private function. Which, by the way, let's click on the links tab. So we got code. Public module, eat and howl, private module, think. And what's a dog think? Typically. Console.code.writeLine I don't know. I think a dog thinks that wants to hump something. That's typically something dogs like to do. Okay, let's get that out of there. And let's see. You know what? Let's just do them all at once. Not only am I going to override, I'm also going to make another eat function. Number of times. So there's going to be multiple eat functions. And the compiler has to choose which one it wants to run based on the parameters given. And we're going to make a local DQ, which is just an 8-byte variable named count. I'm going to start a loop. I'm going to invoke the eat function. I'm going to increment the count. We're going to compare the number of times minus the count. And the jump will happen if the number of times is greater than. And the jump will come back up to here to eat again. Increment the loop. So it's going to eat the number of times that it says. Okay. Let's go over here to our dog. Let's do another eat again. This time the IntelliSense gives us a little drop down. Now there's another little glitch there. It shows 2 eats, even though one's overridden. Not going to worry about that. How do we do that? Let's do 3 eats on that one. And what else do we want to do? Let's howl. Not howl. Okay. Let's do it in. So, you know what? Instead of typing that out, what I want. Oh, yeah, it's up here. I just want to print a blank line. And I have a runtime module called constants W that has some data that's defined for different constants, and the carriage turn line feed is one of them. And let's create and run this. We got a munch, red dog, chomp chomp, chomp chomp, chomp chomp. Ow! And it didn't think. Where's our think? Okay. That's animal. That's the dog. Okay, what I wanted to do, I just wanted to invoke think. I don't like to make a function unless I use it. So I want it to print. I want to hump something after it howls. So all right, let's continue on. We got more to cover here. Don't go yet. It's gonna get better. I promise. Okay, now I'm gonna make another module. Cat. Like that nice big white spot on the screen before it changes the colors. Yeah, love it. Okay, our cat is going to copy the code from the animal. So it's going to eat like an animal. Let's see. so our animal is there. It does have color of blood. I don't want to get ahead of myself here. I'm going to define the animal dot data color of blood as blood color. So you can not only kind of take the data from another module, but you can change the name of it to what you want it to be. And likewise, you can take a function from another module and change its name to what you want it to be. So we're kind of building a cat from other modules. And again, this is not object-oriented programming. I'm going to define animal code echo stats as echo stats. All right, so I got that one. And also, the cat is going to have its own specific function that it can do that maybe a dog can't do and an animal can't do, and that's the purr. It didn't write the end function for me, isn't that nice? Another glitch. Invoke console.code.redline. The cat's gonna go purr. Okay. Now let's go here. Let's copy this line. Put it there. Let's copy this line. Put it there. Notice, by the way, I haven't made any local variables in my, or any variables. I'm just running stuff from other modules that exist. Let's go invoke cat code eat, invoke cat code her, cat code echo stats. And let's create this. Let's run it. All right. My cat says it's a dog, but it munches like an animal, purrs like a cat, and it's got red blood. All right, so the reason it says it's a dog is because I copied that line and didn't change it to say it's a cat. Okay, not a big deal. Okay, so now we have a cat and a dog. There's our animal. It's got red blood, so it's got static data. Again, no instance data, it's not an object. There's a dog who copies the eat function of the animal, but then it overrides it with its own eat function. And then it kind of has another eat function, gives you options of which one you want to call. And it can also howl like a dog, and it can have a private function that's encapsulation, and it can think. So what we're seeing here is encapsulation, and I'm calling an inheritance. And a cat can borrow the eat function from an animal, use the data, blood color, and it can echo the stats using the animal. So it copies the animal, but it can also purr. Now, one thing you got to note here is that blood color is just one piece of data written in one spot, and it's being used by the cat, and I think the dog too. So if you change blood color to anything else, it's going to change it for everybody. You got to remember that. Okay. So now we're gonna scale this up a little bit and get a little crazy. Okay, we're gonna make another module. This module will be a mix between a new type of animal that's a mix between a dog and a cat. So it's going to be a mix between a dog and a cat. I'm going to call it a dote. And the dote is going to have a nice blinky white screen. The dote is going to have some static data. Again, it's not an object. And I'll say public. Again, I'm using an object in something that's not an object. It's kind of like, it's kind of messed up. How do you use an object in something that's not an object and say it's not object-oriented programming when you're using an object? Exactly. Color of blood. Change the value of color of blood dot text. So this animal's going to have green blood. Now, it's also, I'm going to define some things here. I'm going to give it some functions. So it's going to be able to eat like a regular animal. It's going to be able to howl like a dog. It's going to be able to purr. Oops. When you type in the name, that's where you set the casing. So it's this is going to be able to eat like an animal, howl like a dog, and purr like a kitten. And then it needs to have its own special thing it can do that no one else can do. And I was kind of thinking, what's something that if you mix a dog and cat together, it might do? And I come up with bury mice, because dogs like to bury things, and mice and cats like to play with mice. So this dote is going to bury mice. And function. And by the way, I was looking for the word, and when you have one function that has many different variations depending on the parameters, overloading. It's called function overloading. I bury mice. Okay. So let's go over to here. There's our cat. Let's close the cat window. I think we're done making cats. Alright, let's copy. This time hopefully I can change it to a dote. I do want my blank line at the bottom. Let's invoke dote dot code dot eat dote dot code dot bury mice dote code dot howl dote dot code dot purr. Let's run that. See what we get. Okay, we got a dog that can howl and wants to hump something. Cat can munch, purr with red blood. A dote can munch, very nice, very mice. And I might lost my screen. That's another little glitch, is it? I have this window and it sometimes just disappears. Hold on a second. If I have a different window in the background, I don't lose my console window. So our dote didn't echo. I forgot to echo the green blood. So let's go back. Alright. There's an animal. Now you notice the animal can echo stats, but the animal will echo its own color of blood. And if I were to use this function from animal, I would get the animal's color of blood. Whereas the dote, I'm going to copy the function. The dote, there's the dog, there's the dote, has to have its own echo stats function. Color of blood. Okay, let's go back here. There's our dote. Dote.code. Echo stats. And let's create that. Run that. Color of blood green. Press enter. Okay. Fantastic. So this starting to look like composition, encapsulation, and inheritance. All things that you'd consider to be object-oriented programming, but it's not object-oriented programming because there's no instance data. There's no cookie-cutter manufacturing factory of taking one instance and making multiple instances. It's all just one copy, and it's all static data. And it's literally a program without variables too. So we're going to take this a little bit more to a higher level, and we're going to try to make the dote to be an object now. And we're going to make multiple dotes. And we're going to see, so we can see what really is object-oriented programming. So let's do that. Let's go over here. Where am I at here? There's animal. Okay, I'm going to get rid of dog. It just keeps, it's a window I don't need anymore. So now I have data. Now I'm going to make in data. So this is definitely different. If you've been following this video and saying, oh, you know, my compiler can do that, my compiler can do that, my compiler can do that. This is something that's going to be, again, same but different. I'm probably going to say you can do it, but it's, I guarantee it's going to be a little different. So what this compiler is going to do is it's going to make a whole nother section of data called in data. And in the in data section will be the static, it's static data because it's in program space, but only one copy of the data will be there. It's the master copy. So, and maybe other compilers do this and you don't realize it behind the scenes. I don't really know. There's so many compilers. I don't know what they do. But this will be the master copy of the instance data, and when an object is created, it copies the master copy and makes its own copy. And let's just do this, and you can. It's not that difficult. I am going to use an object from the runtime called DWString, and it's going to be called name. And I'm going to change the value of name.text equals Adam. And the reason I'm calling Adam is because the first man was named Adam. And this will be the first object, the first dote. I'm going to name him Adam as well. And I'm going to leave all that the same. When it comes down to echoing stats, I'm going to put invoke console.code.write so.go.write9 name. Okay. So let's go back to here. All this code, I'm not going to change. Let's just see what happens. Then we'll talk about it. How's that sound? Oh, well, that sucks. That was quite shocking. What the heck? I thought everything crashed. Let's compile this. Compiling success. Let's compile. Let's successful. Let's run that. Wow. Wow, on my setup. Let me pause the video and figure out what's happening. Okay, I do have it working, and I'll tell you what happened. It's quite embarrassing. I'm not going to edit out the video because this is real world. So here's the example. I ran it, and it does say the name is Adam on the dote. It can munch, bury mice. It can howl, and it wants to hump things. It can purr. It has a name Adam. Its color of blood is green. Press enter. Okay, so let's go back. That's quite embarrassing. So what's happening here is this compiler, when you do a compile, it doesn't recompile any modules that haven't changed. So this module here, which is the entry point module, didn't change, but I changed a dote. I changed the dote module, and I added instance data to it. And when you do that and you add instance data to it, it changes all the functions within the module, kind of one of these hidden secrets of OOP, such that there's a hidden parameter sent into each function that's the address of the object in memory. But since this module didn't recompile, it wasn't on the echo stats function here. It wasn't sending in the address of the object and as a parameter, but it was still calling it, and it was crashing. So I had to basically make another blank line here to show that this module changed and then force it to recompile, and it worked. And then that sucks. That sucks, but I'm leaving it on the video just to show that this compiler is, we've seen multiple glitches here with this compiler, and this is things I'm working through. And it's one of the reasons why it's not released anywhere. No one has a copy of it because of these things. So, but now back to the main idea as far as what happened. Like, how is this possible? You know, we got this dote. It has instance data. It has the master copy is named Adam, and there is no other copy. Actually, none of these examples are going to use the memory manager and do any objects in upper memory. All this today will be static objects. So this code here, echo stats, the dote, if you don't make an object variable and you're using the I want to call it the namespace. I'm trying to stay away from the word namespace. The name of the module, and you're running the module directly, and you want to run one of the functions in the module, and it has to have that hidden parameter in there of an object, then it's going to use the master object, which is the Adam object, which is a static object, which is kind of why I don't use the word static in any of my declarations, because static, if you say static data, you're referring to the data section, but the master instance data is also static too. So that's why I've taken the word static out of anywhere in the compiler. I don't refer to data as static data. I refer to data as the .data section. Okay, if you're following all of that, great. If you're not, sorry. Um, but we're going to take this next level and we're going to try to create multiple dotes. So let's start that. Okay, so what I'm going to do, I like to make a lot of blank lines to get on the video. I'll make a new function called more dotes. And this is where I need to make, if I want to make objects, I got to make variables. Now, I'm going to make this variable. It's a local variable, but it's not going to be on the stack. It's going to be in the data section. And the one reason I'm doing that is because currently this compiler will not allow you to make objects on the stack. It was kind of a leap of faith that I made, and I'm kind of going with it, and I've been going with it. And there's basically no buffers on the stack allowed and no objects allowed on the stack. And I seem to get by just fine doing it that way. I'm going to name this dote. Oh, I forgot a little thing. It's a dote named Sleepy. I'm going to make local data dote named Doc. I'm going to make a local data dote named Dopey. Okay. I'm going to do a invoke console.code.write line herd of dotes. Now, just for fun, to start out, I'm going to have Sleepy echo the stats, just to see what Sleepy does. Well, let's go ahead and run. Let's run that one. Let's create it. Then let's run it. Of course, nothing different, because just making a function called more dotes doesn't mean you're going to. You have to invoke the function called more dotes. All right, let's try this again. Create it. Run it. Herd of dotes named Adam. Color of blood green. Okay. So what happened here is that it's named Sleepy. That's the variable name. But it took a copy of the master data where the name was Adam. And there's now now there's two copies. There's the Sleepy copy and the master copy. And it's all in static data. Actually, there's actually Doc and Dopey. So actually four total copies. So let's comment that line out. I just want to show you that it first makes a copy. And that's all done, by the way, that's compile time copy. That's not runtime. So this data is all pre-created at compile time. So let's invoke. Now this is where things are going to get a little wild. Sleepy dot. Sleepy has code. Everything has an address and size, but code, it's got functions, it's got variables. So let's take a look at its variables. Name. Okay, I thought it would have more than that, but I guess name is all it gets. Sleepy. So, sorry, you can't do that. Name is an object variable with its own address, code, and variables. So we're going to run a function within the DW string object. What's the function called? So here's the functions I have for my DW string object. And we're going to look down here. New. Okay. Sleepy. Okay. Yeah, so I don't know if that made sense to you or not. So sleepy is an object variable of a dote. It has name as it's one of its instance data members, and that's an object that has code that has the new function where we can change the name from Adam to Sleepy. Let's see here. Let's do a couple more. Invoke doc. Now, I got a little shortcut here. I can do a double dot. Oh, this is what I was thinking about earlier. The double dot notation is something a little different, where you don't have to have the big word variables there. And when you do that, the double dot, you get the functions and the data. And that's kind of like something maybe you've seen in other languages, where a single dot gives you the functions and data mixed together. So now I'm accessing the same name. It's got code. And likewise, I could do the double dot again and go new. Oops. And we're going to name doc. Okay. Now let's do dopey. Dot name. This time I'll do dot code dot new. And whoa. Dopey. Okay, now we've renamed all our object variables. Let's do invoke sleepy echo stats. So invoke doc echo stats. Invoke dopey echo stats. And I do probably don't need this because this is the last example. But I like to put the blank line at the bottom. Okay. So then we got herd of dotes named Sleepy, green blood, Doc with green blood, and Dopey with green blood. By the way, green blood is in one spot. Every single dote has to have green blood. The way this is set up. The reason for that is that our dote here has, in the .data section, the .data section is one copy, color of blood green. The only thing that gets multiplied by when you do the object-oriented programming is what's in the instance data. So your master copy is going to be called Adam, and when you do more dotes, you got to change the name. In code. By the way, I should make a disclaimer here that, I just said that you have to change these values in code. But you did see me use the change the value of statement to change it at compile time. If you were, and that should work. It just doesn't work. So it's just another little thing I need to kind of get into and fix in the compiler. It should be able to do it on the local data variables as well. It's just kind of not working. So let's add to the long list of things that don't work. But there is a long list of things that do work. And I hope this video kind of opened your eyes a little bit. It's kind of a world where object-oriented programming and non-object-oriented programming exist together. And inheritance and encapsulation doesn't have to be an object-oriented programming thing. Now, I haven't mentioned polymorphism in this video, and I'm not going to. And I know what the other video called this polymorphism. I'm not really sure if it is or not, to tell you the truth. I was reading some of the comments and it was saying that it's not, it's just inheritance. Polymorphism seems to be very confusing on what exactly it is. So I'm not going to claim this is polymorphism by no means, because since I don't really fully understand what it is myself. But it definitely looks like inheritance that's non-OOP inheritance. And it looks like I'm making objects, or what is called objects, when they're really just modules. And I'm putting runtime objects in static data blocks in program space. So if I've confused the heck out of you, sorry. But there's more to object-oriented programming and more to what's going on. And none of these examples, by the way, used upper memory manager, who is all program space, and none of the examples used the stack for buffers or objects. And I guess that's all I got. Thanks for watching.